Assalamu alaikum. I am Mushfiqur Rahman. My ID is 1635. Today my presentation topic is process synchronization. Process synchronization is essential for coordinating processes in computing environments. It prevents race conditions and ensures safe sharing of resources among concurrent processes for improved efficiency and system stability. Common synchronization problems. Understanding synchronization. Process synchronization ensures that multiple processes can operate concurrently without conflicts and share resources effectively. Importance of synchronization. Proper synchronization prevents race conditions that can lead to data inconsistency when multiple processes access shared resources simultaneously. Key synchronization challenges. Common problems include the producer-consumer problem, critical section problem, bounded buffer problem, and dining philosophers problem. Producer-consumers problem. Definition of the problem is this problem involves a producer that generates data and consumer that processes it. The challenge is to ensure both can operate without conflicts. Share buffer. A finite buffer exists to store data produced by the producer until the consumer can process it, which poses challenges in synchronization. Synchronization methods. Techniques like semaphores or mutexes are commonly used to regulate access to buffer and prevent overflows or underflows. Critical section problem. What is a critical section? Critical section refers to a segment of code where shared resources are accessed. Proper synchronization is needed to ensure data integrity. Mutual exclusion. Only one process should be allowed to execute in the critical section at any given time to prevent inconsistencies. Solutions. Solutions include in using locks, semaphores, and other synchronization primitives to manage access effectively. Mutex and semaphores. Mutex is a locking mechanism that allows one thread to access to a resource at a time. Semaphore, a signaling mechanism that controls access for multiple processes. Practical uses. Essential for building synchronized application in multi-threaded environments. Bounded buffer problem. Bounded buffer problem is a specific case of producer-consumer problem with a fixed size buffer. Buffer limitation. Challenges occur when the producer adds to a full buffer or the consumer removes from an empty one. Synchronization techniques. Semaphores or condition variables manage producers and consumers when the buffer limits are reached. Dining philosophers problem. This problem illustrates the challenges of resource allocation and synchronization involving philosophers who alternate between thinking and eating. Resource sharing. Each philosopher needs two forks or resources to eat but can only acquire them one at a time, leading to potential deadlock situations. Solutions. Various strategies such as resource hierarchy, limiting fork uses, or implementing a waiter model are proposed to prevent deadlocks. Solution approaches for synchronization. Locking mechanism. Mutexes and semaphores are critical for solving synchronization problems. Wait and signal. Used to achieve processes coordination in environments with multiple producers and consumers. Deadlock avoidance. Strategies to maintain system responsiveness and prevent or resolve deadlocks. Importance of process synchronization. Data integrity. Synchronization mechanisms protect shared resources, preserving data integrity and consistency during concurrent operation. System performance. Proper synchronization contributes to better system performance by reducing contention and maximizing resource utilization. Real-world application. Synchronization is vital in operating systems, databases, and multi-threaded applications, influencing overall functionality and reliability. Common blocking issue. Race conditions. Without effective synchronization, race conditions can occur where the outcome depends on the sequence of thread execution. Starvation. Improper resource allocation can lead to starvation where a process is perpetually denied necessary resources for execution. Deadlocks. This occurs when two or more processes are waiting indefinitely for resources held by each other, necessitating effective strategies for prevention and detection. Advanced synchronization techniques. Read, write locks. allows concurrent access for readers while ensuring exclusive access for writers. Condition variables enable processes to wait until a particular condition is met, enhancing flexibility. Atomic operation invisible operations preventing race condition at lower level. Summary and future direction. Importance of effective synchronization. Effective process synchronization is crucial for reliable system performance and data integrity. With the rise of distributed systems and multi-core processors, synchronization challenges continue to evolve, requiring innovative solutions. Conclusion. Sustaining system stability. Semaphores, mutexes, other synchronization primitives are fundamental for maintaining system stability in concurrent environments. Impact on computing. Understanding and addressing synchronization problems directly influences the design of robust operating system and applications. Future exploration. Continuous investigation into advanced synchronization techniques as well as effective deadlock management will be essential as technology progresses. That's all from me. Thank you.